Yes, good morning, one and all. Yeah, initially, welcome to the final year, and I would like to deal with the mechatronics subject.
ఒడ్లు ఇచ్చిన ఇవ్వండి మేత ఇక్కడ పక్కన వేసి 7 పక్కన తీద్దాం.
Initially, I would like to deal with the mechatronics subject in this particular semester. And related to the mechatronics, there is a vast subject combination of mechanical, electrical, electronics, and even the computer guidance aspects also as well. There is nothing but CSE incorporation, systemic guidance, and the programming languages need to be incorporated indeed to operate our mechanical components with the help of electrical connectivities. And there is a technical term of this electrical connectivity. There is an different types of connectivities here in the electrical field of view. First one is that is what we will be calling as an wire connectivity, and without wire connectivity, there is signal transformation systems, and further signal transformation systems, the transferring zone will be accessing, and even the transferring zone also consists of different types of sensors that will be learning in this particular subject, how that signals are being transferred from one place to the another place, how far it can be transferred, that signals can be transferred, that is nothing but the distance between the source point to the destination point. And these and all of the criteria will be learning in this subject. The technical word for this transformation or connectivity is bus interface unit. BIU will be calling it as bus interface unit only. Anyway, we'll be looking with this particular term in detail in our second unit. Moving on with our major concept is mechatronics. So what is meant by mechatronics? So mechatronics is the synergetic combination of both the mechanical as well as the electrical systems. So it is a combination of both the branches as we have been already discussed. There is mechanics. It has been taken mecha. It is a Japanese word, mecha, and after that it has been converted to the mechanics and electronics. And from the electronics, tronics has been taken into the force, and after a combination, mechatronics has been came into the force. So the technologies related to both the mechanical aspects as well as the electronic guidance system is being merged indeed to obtain a particular component which will be operated by the combination of both the technologies is called a mechatronics system. For this, we can consider a best example that our mobile phone itself, mobiles, and even different automobiles also as well. Some of the components which are being worked in our domestical basis as well as robotics, and the most advantageous of these mechatronics is nothing but incorporation of this combination technologies in robotics field, and that is a major advantageous point of mechatronics. Moving on to the basic definition of mechatronics, depending upon different authors related to different fields of the globe, we are they have given different kinds of definitions, and in this we'll be looking after one by one periodically. Mechatronics is a synergetic combination or integration of sensors, actuators, signal conditionings, algorithms, etc. as per the guidance of T. Mori. And we have been already discussed that mechatronics is a synergistic combination of sensors, actuators, this and all of the considerations or components, signal conditioning. This will be existing in electrical department, that is ECE combinations, and power electronics will be related to the triple department, electrical and electronics department, decision and control algorithms. This is nothing but, and even the computer hardware and software to manage the entire complexities. Nothing but indeed to operate these sensors, actuators, and giving signals to the signal conditioning units. Majorly, we require the power. Power is the major source. So this power will be supplied at different fields at a particular voltage levels by the triple department, and entire the algorithms need to be worked from st- starting stage to the ending stage in an sequence manner. In an sequence manner will be programmed in the microprocessors by generating a program with respect to the computer guidance, and this is the task of computer science department. And the combination of these three will be incorporated in the mechanical components, and those components design has to be performed by the mechanical candidates. So those are only the components which are processed internally within the object that is being manufactured, but the overall considerations has to be performed by the external component. So that external component is nothing but a robot, and entire this is circuits, components, and programs overall will be merged within the mechanical components need to be worked, that need to be worked, and hence those will be programmed by the CSE. And next, these overall design work, framework, and modeling work will be performed by the mechanical candidates. That what we'll be using in our CAD software, CAM software, ROI, the three-dimensional softwares, and we will analyze the design processes that has been performed in the softwares with respect to our ANSYS, and even the some 3D three-dimensional modeling sources and analysis sources. And moving on to the next definition that has been given by Heishma and Tomizuka. The synergetic use of precision engineering control theory, computer science, and sensor and actuator technology to design improved production process. So here, precision engineering, precision engineering in the sense able to do the task in an action mode. So that action mode need to be performed by your mechanical engineers. And control theory, computer science, sensors. These are related to the rest of the department that we have been discussed presently, right? So the movement or actions that has to be performed by a object with the combination of these and all the components related to the interdepartmental components is called a mechatronics. Moving on to the next basic definition, that within the India that we are following, US and India, the standard author W.B. Bolton, Mechatronics and Electronics Control Systems in Mechatronics, Mechanical Engineering. So the definition given by Bolton was, it's a field of study involving the analysis, design, synthesis, and selection of systems that combine the electronics and mechanical components with modern controls and microprocessors. So here we have to notice the interconnectivity between the interdepartmental components. Here, look at this analysis, design, and synthesis. So synthesis, design, analysis related to the material selection, fabrication work, design processing, modeling analysis, and these and all are the things that will be performed with mechanical engineers. in the CAD software, CAM software, ProE software, and we'll be analyzing whether the dimensional accuracies are maintaining or not by ANSYS and the related softwares indeed to analyze the design processes. And selection of systems and combine electronics. So electronics, it involves the electrical power supply and the interconnectivity that we have been discussed initially. There is bus interface unit. There will be a major control that will be calling as a control system, and from that control system to each and every component or each and every part of the robotic field, the instructions will be getting passed only by that particular microcontroller. Here we have been given components with respect to the modern controls and microprocessors. So controller plays a major important role. And here the microprocessor. Processor is one of the part of the controller, and processor is the device which stores the programs that we are being dumped to the system. And depending upon the program only, entire the components will be getting accessed. And here the bilateral devices has to be utilized, that is transferring zone as well as the receiving zone. Hence we will be calling it as an trans receivers, so transmitting the signals as well as receiving the signals, like our internet. Just like we'll be taking one simple example. We'll be opening your Google Chrome, and you would like to search related to the mechatronics subject. So you will be pressing the mechatronics. Simultaneously, you are giving the pressing the mechatronics word, in the sense you are giving input to the IP, nothing but internet sources. So that provides the feedback that upon that particular word, how many results are being existing in a global wide range. So you will be getting the entire results. In that you will be selecting the proper result. So similarly, transferring zone as well as the receiving zone, that is we are calling as a trans receivers, will be placed over there. And most probably this mechatronics is an complex decision making systems will be merged indeed to activate, to process the actions in a simple format. And that is a major advantage of this mechatronics. Moving on to the next, mechatronics. So standard format or definition that we are following in our India, that is mechatronics is a synergetic combination integration of sensors, actuators, signal conditioning, and this is the definition that has been given by the W.B. Bolton, and even the textbooks related to this W.B. Bolton author is also existing in our library also. You can go through it also. Next. Okay, what are the disciplinary foundations of mechatronics? So mechatronics, it's okay. How many subcomponents or subsystems or sub-elements are existing with respect to the mechatronics? Here we have a clear picture or skeleton of this mechatronics. It is a basic control system which will be accepting the overall guidance from the guidance or results that has been performed the work in the mechanical systems, the mechatronics. Simultaneously the electrical support will be getting to the mechatronics. Simultaneously the control systems will give the guidance to the mechatronics, and the informatics systems, nothing but the programmings need to be dumped to the electrical components. So informatics systems will be existing with respect to the information systems that will be getting over here, and these will be getting passed to the control systems, and these control systems will give the feedback to the mechatronics. And for that, indeed, to operate these both the sequences or mechanical systems, we need the electrical power supply. For that, this electrical power supply will be transferred or supplied. So the integration of four different subsequent characterizations is a combination of this mechatronics systems. So here we have been discussed already in the departmental strategy. Mechanical systems is an integration. Electrical systems, that is triple E, it is an integration. Control systems, that is ECE, related to the mechatronics, and informatics systems, that is related to the mechatronics. So in this mechatronics subject, you are touching with respect to the four different departments. And four different departments information has been merged in your syllabus point of view, and you will be able to learn in this mechatronic systems, right? Okay, multidisciplinary another. So multidisciplinary in the sense, here we are learning the different fields of subject knowledge related to electrical, triple E, and next the CSE, as well as we are having the technical depth knowledge in the mechanical engineering. So design processing and all will be taken, and the basic informations related to the electrical department which are required to operate our mechanical systems will be learned simultaneously. What are the programs that has to be given to the mechatronics or mechanical systems to be worked without any human involvements? So basically mechanical systems are physical systems, or which are having a semi-physical systems. So physical systems in the sense, the generator that you need to be switched on upon rotating the armature, that is mechanical system. Later on, electrical power supply, the motor has been connected, and electrical power supply, if you have been given, that rotor will be connected to the electrical motor, and hence the shaft will be getting rotated. So that is a second object we have been attained. So the next generation, it is the incorporation of sensors, and the sensors need to be operated with respect to the program given by the informatics system, and this program will be stored in the sensors, and we will be giving just signals to the sensors need to be operated this entire mechatronic system. For this, we'll be having a simple example that is being progressed in our domestical basis. In the present days technologies, this lot of ventures has been existing, and construction basis, in the construction basis, 2 bedroom flat, 3 bedroom flat, like we are being getting any number of updates. In that, we'll be considering in a bedroom. When a person entering into the bedroom, automatically the sensor will senses and light will be automatically switched on. Even the fan also will be automatically rotating. And by grasping the voice signals, the rotations, RPM, the rotations per minute also will be getting set on. So the present days technologies and the ancestor technologies we are having is nothing but the potentiometer. Upon rotating of the potentiometer, the electrical flux will be getting generated, and upon the increasing of the voltage, we will be getting the RPM increment. So that is the present days technology. But we have been entered into the update technology, futuristic technology presently. Upon our voice signals, automatically it will be RPM will be decreased as well as it will be increased. And another one more point, it is when the person is entering into the room, automatically the light is being sensed and it is getting glowing. It is getting glowing. So this is a combination of multidisciplinary aspects. That is nothing but the mechatronics, and without the human involvement, physical appearance, physical action అండి, not the appearance, actions. Indeed to switch on, మనం స్విచ్ ఆన్ చేయాల్సినంత అవసరం లేదు. No need to switch on. That is physical attachment is not existing. Next one, it is there is no need of physical contact with respect to the potentiometer increment. Indeed to increase the RPM. That is one of the advantage. Simultaneously, in your hand systems also you are existing. You are utilizing one of the mechatronic system. Nothing but our Google and voice recognizer is being installed over that. And when you are pressing that, automatically whatever instead of typing, whatever you are speaking will be getting grasped and related to that, the information is getting back to you. So that is also the mechatronic system. So hence cross-disciplinary or interdisciplinary or multidisciplinary aspects. So two or more disciplines, one discipline, or act on a static representation related to only the one system. Overall, in the futuristic basis, the combination of these all technologies given to a birth of this mechatronics. That is the foundation of mechatronics. Okay, what is the design for this mechatronics? How this processing will be getting done, and we'll be seeing now modeling and simulation. So first one, it is indeed to manufacture or indeed to frame up a component need to be released to the market. We will be having one representations, that is schematical representations or drawing representations. That drawing representation will be calling as an modeling. Related to that particular physical drawing, you will be modeling with respect to a software device, and you need to simulate it. Simulation in the sense laboratory working process of the entire component after the design performance before getting manufactured. So just like it is just like simulation is nothing but uh, in the present days technology, the simulation process against the coronavirus is being performed in the laboratories. Almost majority vaccines are being manufactured, and vaccines trials, we are calling it as vaccine trials. We are getting the daily updates. The trials are being performed only in the library by choosing a particular candidates. So whether it after getting succeeded only it will be released to the market. So similar way, that is called simulation process. Laboratory process, all the phases of the laboratory process is called simulation process. Similarly, indeed to release a product into the marketing sector, we need the simulation process after getting modeled. So modeling is nothing but parts preparations, different components required from the interdisciplinary departments, gathering, assembling, and the simulation activity need to be performed. Simulation in the sense working action before getting manufactured, simulation process will be getting done. So in that simulation process, what are the different technical points that will be involved? We'll be seeing in detail. Recognition of need. So recognition of need in the sense whether the survey that has been done, that particular product which is need to be manufactured is not existing in the present environment. That is the first point. So the object which is not being existed in the environment will be surveyed and will be giving feedback to the or report to the concerned company, and that company will take it's an quotation, and depending upon that quotation, the research activity will be getting progressed. So second one, it is nothing but the conceptual design. The research activity starting point is nothing but the conceptual design. So for getting that particular output, what are the design parameters that has been required, that has to be drafted, and what are the mathematical calculations? Mathematical calculations in the sense dimensions and length, breadth, thickness, and circumferential areas, how much it will be required. That is all or the calculations existing in the mathematical modeling. Without that, the assembly conditions, if the mathematical calculations has not been performed and the manufactured at the time of the assembly calculations, clashes will be getting done. So indeed to rectify that, the mathematical calculations will be made, and as per the statistical basis of data, the design progress will be getting done. Next one, what are the different types of sensors and actuators are required? So actuators in the sense here, the working motion containing objects are called actuators. Nothing but our synchronous motors, asynchronous motors, and lever type systems, butterfly type of systems, taps, connectivities, overall the considerations which are performing the actions is called the actuators. So sensors are nothing but the signal transformations or signal communication systems from one actuator to another actuator. Those are nothing but the sensors, signal graspers and signal transferring systems. Next one, development of a detailed model. So entire the project need to be drafted, and the drafted project will be modeled, and that modeling has to be performed later on in the next stages. So control systems. Here, indeed, to operate the overall model, different types of control systems are needed. That is open loop control system, closed loop control systems are the two basic control systems existing in our theoretical basis, and as well as we'll be looking in the our subject also as well. That is open loop in the sense there will be no any feedback, nothing but we'll be considering our pump. Just will be taking that opening the tap, and some amount of water is getting dropped, and we are washing with the particular water. So there is no any count of that quantity of water that has been released from the pipe, and that is nothing but the open loop control system because there is no any feedback. So second one, closed loop control system. Closed loop control system, considering the same example, for washing our hands, we have been opened the tap, and for washing our hands, how much quantity of water we have been utilized, there will be an measurement. So that is called closed loop control system. So for washing our hands, 1 liter water has been utilized. So 0.75 liter of water has been utilized. 0.5 liters of or half liter of water has been utilized. So measurement device will be getting specified at the end of the outlet, and that quantity will be measured. That is nothing but the feedback control. So that feedback, and this feedback is helpful for us for desired considerations, and nothing but there will be some statistical analysis. So indeed towards the hands, only half liter of water has to be utilized. So sensors will be placed over there, and when the hands has been kept at that particular pace, the sensor will detect, and automatically water will be getting dropped down. So after completing that half liter, automatically it will be getting switched off, and we are looking after this particular mechatronic technology in different shopping malls also in the nowadays. Next one, optimization. So optimization is nothing but utilizing the technologies full-fledgedly, but need to be minuted in strategy. Need to be minuted in strategy, and nothing but we have to be utilize the entire sources within less conspiracy. So highest amount need not to be spent on that particular system. Next one, moving on to the next topic, that is prototyping. After getting modeled, prototype need to be done. So prototype is nothing but incorporation of the interdepartmental strategies, nothing but power supply, and some of the components need to be existed in need to transfer the signals, or that program need to be executed. That executing program output need to be grasped to the control system, and that control system need to give the guidance to the actuators to be functioned. So these and all are the tasks related to our hardware design and simulation and design optimization. So design optimization in the sense economical constraint should use the less amount for better output. So that is nothing but the optimization in simple words. So hardware design. So without this hardware design, whatever the components or software aspects that we have been installed before will not be getting executed. A simple example for this, uh, in our computer laptops, initially operating system will be getting installed, OS, and so with after getting installed that OS, later on it is the basic control unit which accepts the software that has been installed, and the working will be getting progressed after the installation of internal softwares. So indeed, to support the softwares, hardware is the basic source. Simultaneously, for getting all these benefits, the hardware design and for getting simulated also, hardware design plays a major important role. That is nothing but the prototype technology. The laboratory process before getting manufactured full-fledgedly will be related to the prototyping. Next one is development. If the prototype design and simulation is getting okay or got up to the mark by getting the considerations of optimization, then we will be moving on to the development of software and manufacturers and testing lifecycle. So if at all these testing has been got done, or within the limitations we have got the design parameters, then it will be moving for the manufacturer, or else again the considerations need to be changed. That is nothing but moving on to the first point. If it has been got executed by satisfying all the required points, it will be moving on to the workshop and will be manufactured. And simultaneously, if at all not maintaining the statistics, the modifications are required from the starting stage onwards. And again, in this particular range, the modifications will be getting done. And again, the hardware support need to be taken, optimization technologies need to be found, and the development activities will be getting progressed. So after the modifications, if the design parameters satisfies the required criteria, then it will be executed for the manufacturing, or else again the modifications need to be progressed from the initial state onwards. And this is the cyclic process. Mechatronic design will be progressed until and unless the required criteria has been maintained. All right, so that is the uh, systemic zone of mechatronic control system. Next, what are the different objectives of mechatronic systems? The objectives of mechatronic systems. It is an integration of mechanical systems and electrical systems. It is a common point in each and every phase, either the fabrication range or the basic controlling parameters zone. And next one, it is controlling to the processing zone. And even the at definition point of view also, we are having the combination of electrical and mechanical, but computer guidance will be getting efficacy. Next one, to improve the efficiency of the system. The major objective is to improve the efficiency of the presently existing system. Nothing but you have been already performed the actions in the control with the control devices in the mission tools lab. So mission tools lab, you need to be getting switched on, and later on the tool need to be fixed up, etc. process has to be performed. That object need to be fixed in the chunk, and you have to place the tool in the tool holder, and you have to rotate the armature and need to be taken in contact with respect to the work is that particular tool, etc. Physical operations will be getting involved. So there will be a program for entire these tasks performance also. Automatically that tool will be getting changed with respect to the ATM factor, automatic tool changer, ATC, with a program. Required tool for milling, there will be a separate tool. Drilling, there will be a separate tool. So related to the working process, automatically depending upon the program that has been given to the system, it will be getting changed. Tool will be automatically getting changed. So that is nothing but the improving efficacy. So by the working efficacy of this particular programming nature, the entire task will be getting performed on the work part within a 5 minutes. So physical parameters in the sense, it will be taking more than half an hour of time. And even the efficiency, nothing but the dimensional criteria also will be getting changed. So accuracy will be very much high. That is a major objective. Next one, to reduce the cost of production. So cost of production also will be getting reduced. Nothing but within the half an hour, 5 different products will be getting manufactured. If that process has been done manually, only one product is being manufactured, and even time lapsing also will be getting decreased. And having high accuracy and precision, easy to control the system, and customer satisfaction and comfort also will be existent, right? Okay.